right. Yeah, it's been a while since I posted the last part, so I'm just going to start with a brief recap. This is a pretty good time to recap anyway, since we've just finished in the last part, part nine, um, the the main game. Sure, with the random strategy, which is like the worst strategy, but that's okay. So if we scroll up in our code here, we had some initial functions that just hide and show errors, and we also went through this creation of a random set of boxes. So if you remember right, we wanted to create 100 boxes with random numbers inside them. So if I call create random boxes with 100, this creates something called an array, and it fills it with the numbers 1 through 100, and then calls shuffle array, which just shuffles all the elements around and then returns that set of boxes. Shuffle array used just an algorithm here that we talked about last time to just swap random elements in the list one at a time, and that actually does produce a nice random array. So that was good. And we did some stuff to show calculating for longer running operations with request animation frame. And then we had the main actual run function that did things. So last time we did some error handling, as you can see. If there's less than 2 students, we can't play the game. If the number of students is odd, we can't play the game because they have to pick half the number of boxes. That'd be kind of weird if it was like 3 students and they get to pick what, 1 or 2 boxes. That kind of doesn't work right. And then we just went through and played the game, right? We said, okay, let's track the number of wins we have and go through however many iterations we've defined. Again, this is a Monte Carlo kind of thing. So 10,000 we started with, but we can change it to anything we want. Within reason, obviously, the computer needs to eventually finish. And then we just said, okay, set up the game, create random boxes with the number of students. So 1 through 100 in this case, possibly, if we had the number of students being 100 here instead of 2. And then we just say, okay, play one game with these boxes, and that returns back the number of students that won. And if the number of students that won, so like, remember that they all play until one of them fails, and then we stop. So like, let's say the first 3 students actually find their box, but then the 4th one fails, then we'd return 3. If the number of students that won happens to be equal to the number of students, i.e. all of them won, then we track that as a win. Otherwise, we don't. And then we do some formatting here so that we can see nice numbers here. And if I switch back to number of students 2, you can see, yeah, this is working. You know, we're seeing the number of wins out of 10,000, 2494, which is 24.94%. Not too surprising. So what does this play one game do that we wrote? This function right here is down here. And that just says, okay, we're playing one game, go through each student. Let student be from 1 to the total number of students, and just play that one game for the student. Have the one student go into the room, choose their half of the boxes, and basically if that returns a 0, that means that they failed. And we return S minus 1. This again was, well, S minus 1 students won. If student, S fails, then the previous ones must have succeeded, or else we would have already bailed out. So if S is currently 4, like in our previous example, and we actually lose, we return a 0 from this just play that one game for the student function, then we will return 4 minus 1, which is 3. The first 3 students won, the 4th student failed. So, and then we keep going down, right? We had broken this into pieces. Play one game for a student. So play one game just runs through all the students and says play one game for a student. Play one game for a student now is actually going to do the real work. So the student enters the room. That's what this function's all about. And they get to open up to half the boxes, right? So boxes to open is boxes.length divided by 2. That was, again, an array. We learned about .length last time. So it says if there's 100 boxes in this array, then this divided by 2 will give us boxes to open as 50. And we just loop through 50 boxes, and we choose a random box between 1 and 100, whatever boxes.length is again. We look inside the box. So notice this bracket notation here, again, is something to do with lists or arrays. We say go in and take chosen box -1 and get me the number at that position in the array. So if the array was only 3 long and had the numbers 3, 2, 1 in backwards order, and we, so what we're saying is give me, like, let's say the first box in that array, which is 3, or give me the second box in that array, which is 2, or the third box array that is 1. We learned last time that arrays are 0 indexed, meaning the very first number is number 0, then the second element is number 1, the third element is number 2. It's all off by 1. So this is a pretty common pattern. Chosen box might come out to be 1 through 100, but the list elements of a 1 to 100 array are actually numbered 0 through 99. So if we access the 0th element, it'll give us the number in the first position. And the first position, number position 1 will give us the second element and so forth. All that to say, chosen box -1 shifts the 1 to 100 down to the 0 to 99 that we want, and then we access the number in there, and that tells us what's the contents of that box. And then we say, is the contents of that box equal to the student number, right? That's the entire game. Did the student find their number? Their number is stored in the variable s. That's the student number. If so, return a 1. Hey, they won. Otherwise, return a 0. Remember, 0 means we lost, and that's how we know to return all the previous students won, but we finally found one that lost here. Or if we actually get through this entire loop and try every student, we return number of students. They all won. And if you remember right up here, number of students coming back right here is the condition for us actually winning the entire game. All the students have to have found their number when choosing half the boxes. So that is the brief recap. We're now going to add a few more strategies. Okay, so let's see what another good strategy might be. Well, maybe not good, but a slightly better one. So let me switch over to the slides here. There is an interesting thing you might have already noticed. That is the random is a little too random. So with the random strategy we've been trying so far, students may actually pick the same box multiple times. So in a 4-student game where each student's allowed to pick 2 boxes, the way we had it currently written was just pick a random number between 1 and 4 and pick it, and then do that again a second time and see what happens. Student 1 may come in and pick box 3 twice with that code. That actually is what that code says. Just pick 2 random numbers. Could be the same one for all you know, 2 times in a row. That's not exactly what we would do as humans. Now, in fairness, if I was asked to go into a room and pick 50 boxes at random, I might forget after 20 boxes that I picked box 72 back at like the 3rd box or something. So let's assume these students have really good memory, or that we at least allow them like a sheet of paper that they have to take back out of the room with them. They can't leave it or anything like that or show it to anybody, but like, they can actually write down which boxes they've chosen so that they don't randomly choose the same box. That is in the spirit of the original problem, is that they have this memory and they don't have to pick the same box twice because they forgot. That's just not fair. Okay, so the solution here, of course, is just to make the students remember which boxes they've chosen. So in code, we could try to do some kind of memory thing where we remember, like choose a random number, remember that we chose that random number by inserting it into an array, and then choose a random number the next time. But just like if we accidentally choose the same number, like we look through the array and say, oh, we've already chosen a 5. We chose a 5 again. Let's just choose another random number until we get one that's not in the list that we've already chosen. This is okay, but it gets rather inefficient as your array gets bigger. You're choosing a random number. By the time you've chosen 50 boxes, you're almost always choosing at least 2 random numbers to get a valid box that you haven't chosen already. So there is a better way, and that's here. So in code, instead of choosing a random number 50 times and possibly remembering things, why don't we predetermine the set of 50 random boxes we're going to choose? So this would be like the student walking into the room, be like, you know what? I'm going to choose box 3, 7, 27, 17, 64, blah, blah, blah. Like write down 50 numbers, making sure they're all, the right numbers, let's say. Sorry, there's no duplicates in the list. And then just picks those 50 boxes and that's it. So maybe another way of phrasing this is imagine a student writes down the numbers 1 through 100. Like each student is just given this when they go in the room, let's say, so they don't have to waste their time. They just cross off or circle the 50 numbers like in the list that they're going to do randomly. And then they just go through that circled list and do it. That's what we're going to do. We're going to have them predetermine those 50 boxes and choose them. Now, notice there's a cool way we can do this. We had already, if you remember right, created a create random boxes function to set up the original problem, right? Like we set up 100 boxes with random numbers in all of them, right? We basically just did this by creating 100 boxes with the numbers 1 through 100 in them. And then we called that shuffle array function that just mixed them all up. What if we just do that again, but then just choose the first 50 of those boxes? It takes the numbers 1 through 100, shuffles them, and then we just take the first 50 and say, yep, those are the boxes that we're going to randomly choose. That actually accomplishes what we want and does so with a function we already wrote. So it's great. We get to reuse this function. So that's what we're going to do. So I'm going to go back to my code now. Exit this. So for starters, let's actually put a real strategy in the second option. You'll remember that we had said random and random 2 just because we knew we were going to do more strategies. Well, random 2 is now random with memory, right? So that's exciting. We actually know what our strategy is going to be. I'm not going to tie it together yet, though. So I'm not going to make this do anything else until towards the end. I want to just write down the function we just described. So I'm going to go down here and actually make a function called function choose random box with memory. Okay. So the whole point of this function is to actually do what we said, to basically here, instead of choosing just a random box, we want to choose a random box out of that first 50 elements of the 100 shuffled array list that we create. So if you recall correctly, we're going to create that up here with this create random boxes function. So remember, create random boxes just takes a number, it's 100, let's say, and it creates 100 random boxes by just creating the boxes 1 through 100 with the numbers 1 through 100 in them, and then just shuffles the array right down here on line 21. So that just creates a random ordering of the numbers 1 through 100, and then we're just going to take the first 50. All right, so how do we do that? Well, I'm going to call my create random boxes function up here, right? Let's just call this on the number of students that we have, or the number of boxes, either one, they're the same. Create random boxes, num students, let's say. So that calls that function with the, like number of students, which would be 100. And we're going to assign that to a variable like let boxes to choose equal this, right? Now you'll notice I don't have a number of students yet. That kind of needs to be passed into this function. That's one of my inputs, students. So let's assume whoever calls choose random box with memory gives us the number of students, which is 100. We say, okay, create that many random boxes. Now notice this just creates a random ordering of 100 numbers. We only want 50. So if you recall from a while ago when we were talking about arrays, there's something that can slice up an array, cut it down, called dot slice. And dot slice just says, okay, give me the start and the beyond last index. So what that means is, like, if I say 0 to 50, it will actually give me the number 0 to 49. It says stop at 50, don't give me 50 is what it says. So let's do that. 0 and num students divided by 2, right? So this says create the 100 random boxes, slice the array, like cut it, in this case, in half. We say cut it starting at 0, so include 0, but stop including, like exclude, starting at number of students divided by 2, which is 50. So we'll get the numbers, we'll get the first 0 through 49 slots in this array. So that's the first 50 random numbers. So these are going to be our boxes to choose. Cool. Okay. And then I just need to return which box I actually want to choose. This says choose a random box with memory. It doesn't say like give me 50 random boxes all at once. So I'm going to return here boxes to choose, and I'm going to access the sum position. I'm going to call it I. Like, give me the ith one. I need this to be an input to my function too. So this is one way which you'll often produce inputs to a function. Sometimes you think of them in advance. Sometimes you just kind of start writing the code and realize which inputs do I actually need. I happen to do it the latter case in this, the latter way in this case. So notice if I call this function choose random box with memory, I equals 0 with number of students, it'll create the boxes to choose, slice it up so I get the first 50, and then it will return me the first element in this array. And what I want to have happen is when I call it next with I equals 1 instead of 0, it'll just give me the second. It'll just choose the second one in this list already created. The problem is I didn't write that yet. Here what I did is I said create a random box every time you call this function, and then, you know, we'll return that position, whatever the ith position is that you give me. So the idea here is that you would call this function right here and just feed it this I. And so as you're calling I equals 0, I equals 1, I equals 2, going through up to I equals 49, you'd just be calling this choose random box with memory, and it would just be returning you the 0, 1, 2, all the way up through 49 elements in that array that we created here. But I only want to create the array once for that entire sequence. Otherwise, I'm not doing any good. I'm literally creating a completely random new set of 50 elements each time, and then returning the next position in it, which could be the same box again, for all I know. If I'm creating new random sets of numbers every time, I have no continuity of which boxes I've chosen and which I haven't. Okay, so that's not too hard to handle. I can say if I equals 0. So again, remember our brackets here and then the curly brackets. So I only want to do this on the first shot, right? Seems reasonable. Problem with this is that A, boxes to choose is now not stored still between function calls, right? All variables within a function that are using the word let are destroyed at the end of the function when the return happens. So I actually need to make this a global variable. So basically I'm going to say let boxes to choose equal an empty array. And then in here, I'm going to say boxes to choose equals create random boxes. What this does is creates the boxes to choose variable outside the function. It's now a global variable. Not great, but it keeps memory around even across calling the function multiple times. And then what we do is when I equals 0, we say boxes to choose equals our 50 random boxes. And then we just return the ith one each time. So only on the first shot do we create the random set. And then from then on, when I equals 1, 2, 3, we're just returning the subsequent elements in boxes to choose. So that's what we actually wanted to do. That's the function we had described. Let's see what this is looking like. So I'm going to do a console.log here. Boxes to choose. Boxes to choose. And then let's actually just call this function, this is again very temporary, as we might here. We'll call it, it'll first be called with 0 through 100. So I said choose random box with memory. I'm just calling my function 0 to 100. And then the next time on the loop, it would call it with 1 to 100, 2 to 100, and so forth. We'll only do 3 of them just so we can see what this looks like. And let's open our console and see, let's clear this, and then let's comment this line out, and then add it back in. Okay, cool. So you can see each time I save, it actually runs this code directly before I've even pressed the run button or anything here, because this code is not inside of a function. So notice both times when I commented the line out, it ran the code, and when I uncommented it ran it again. Notice all it did was did this one console.log function. And it only did it once, right? Because here I said I equals 0, I equals 1, I equals 2. These, when I called this with I equals 1 and I equals 2, skipped over this code. I was not equal to 0, so it didn't do it again. So we don't have multiple times that this boxes to choose is being printed every time I call the function. It just happens when I call it on the first shot with I equals 0. To see the difference, if I call all 3 of these with I equals 0, notice I get 3 boxes to choose. These were the first 2, and then these are the 3. Like, it actually created a new set of boxes 3 times. And notice it is doing what I want here. It's creating a list of 50 elements. It says object array 50. And it did randomly choose an ordering of 50 boxes. Not all of the boxes are in this list. I don't see the number 1 in this list, for instance. I do see a 5 and a 9 and a 4 and a 6. So yeah, things like that. But some other ones probably do have the number 1 in them. This one has a 2 in it, for instance. I don't know, your eyes may be better than mine. So it's doing what we want. It shows a bunch of random boxes. We aren't seeing the return value, so let's actually look at that now. Let me console.log each of these. I equals 0. Console.log I equals 1. And let's actually make that 1. And then console.log, so that we'll actually see this return value, return boxes to choose. So I equals 2. And let's make that an actual 2. And then let's clear our array here. And let me just, yeah, do something like that. Okay, so you can see now, I saved it twice, so it ran twice. Boxes to choose was chosen as those 50 boxes. Notice when I equals 0, we return 75. When I equals 1, we return 67. When I equals 2, we return 15, and just so on and so forth. As I cycles through 0 to 49, we're just going to return these 50 numbers in order. Ooh, number 1. Yay. So that's it. Except that we're not actually calling this function in our main program yet. So let's do that next. And to clean up things here, I'm going to delete these now. Delete my console.log, and I'll clear this and close the console too. And so now we're actually going to just use this function and try it out up here. Now, I don't want to lose this code right here. Not that it's hard to make up again, but notice that I can make this into a function too, right? This is just choose random box. So let me come down here and say function choose random box. And I'm going to give it the same exact inputs, even though I don't need I for this one. Notice I do need num students, which is the same as boxes.length. So here, I'm going to copy this and just paste it in here. Return this. I'm gonna change boxes.length num students here, because that's what that means. Semicolon on the end of that. So notice now we've just made a function that does exactly what this code does. When we choose a random box out of num students, it just says, okay, if you give me 100, I'll choose a random number between 1 and 100 and return it back to you, completely ignoring this I value. Why am I putting the I value in there? Let's do that right now. So here, I'm going to replace this random number thing with just my choose random box function. And I'm going to say I comma boxes.length. So remember, I was going to be passing I in here to both my functions. Boxes.length is the number of students. Again, there's 100 students, there are 100 boxes. So this allows me to quickly switch out this function. So here, I've so far changed nothing. Choose random box, fills in boxes.length into number of students. I call my random number 1 to 100, 1 to number of students, return it. It does the exact same thing as it was just doing before. But if I switch this to with memory, notice it now calls the other function. everything works the same as before, but now it's using all of my new code to actually pick a random box out of that first 50 slice that I took of the random 100, and it's actually returning one that's never going to repeat a box. So that's not quite what I want yet, but it's getting close. So notice, choose random box. Let's run this. I'm going to do 4 students here. Notice I'm running this, and I'm getting things like 3.8, 3.5. I got a 4 point something in there. I'm getting a lot of numbers in the 3% range here. And notice if I change to random box with memory down here in code, and then change this back to a 4, now I'm getting 6.25, 6.6, 6 point whatever, 5.7. I'm getting a higher percentage of wins. Now notice I didn't change this yet, right? I haven't tied my code to this choice yet. I'm going to do that in a second. But notice it is doing better with this strategy. I just manually inserted that strategy into code. All I had to do was change this function name, and suddenly I changed strategies. That's why I included the I here. Even though it's useless, I can't as easily just change which function I'm calling if they take different inputs. So it's actually easier to just include a input that I won't use to one of the functions if I need it for another strategy function. And then I can just switch the function name and I'm done. That's how I can choose between strategies. Cool. So with that, now all I need to do is actually change this function name right here based on whether I click this or this. So that's what I'm going to do next. So let's go back up to our main run code. We need to actually grab this strategy, just like we've done with number of iterations, number of students, etc. I don't need a parse int like before, right? This is not a number, this is a strategy. So I'm going to up here say const strategy equals document.get element by ID, put a semicolon at the end of that, and then the ID I want to get is, well, strategy. That's the ID right here. So this is my random with memory strategies. Just grab that strategy, please. Now, if you recall from the previous set of videos where we talked about options having values so that they're easier to compare in code, we're going to do that again here. I'm going to say value equals random here, and value equals random memory. So again, this isn't necessary. If I didn't do this, strategy would be random with memory, an entire string with spaces in it, and I'd have to get the capitalization right and everything. With value, this lets me change this text without changing the code down here that is used to pick which strategy I'm using. Basically, this just says, no matter what this text says, always return random if I call .value here. So this says strategy now equals either random or random memory if I pick the first or second option, and I don't have to worry if I change this, let's say, to a lowercase m later or an uppercase m. Like, that won't change the functioning of my code because this hasn't changed. So values are more stable. We generally use them for options. Okay, so I've got my strategy, and I come down here, and I want to come up with which function I want to choose. So let me just say, let choose box function equal null, something that's just useless. I don't have a function yet. And then if strategy equals random, then choose box function equals the one down here, right? The first one, the first strategy, choose random box. So I'm going to copy and paste that up here. Notice I don't have any brackets or parentheses on this because I'm just saying this is the name of the function. JavaScript allows us to do this, to pass functions. Yeah, we believe we've seen this before. And so we can just say choose box function now has this function in it, and I can call it by saying choose box function brackets rather than saying choose random box brackets. So this stores a function, and I can call it with the parentheses or brackets on it with some inputs. And if this variable stores this function, it'll call this one. If it stores a different function, it'll call a different one with the same inputs. So let's do that part now. Else if strategy equals random memory. So again, I'm matching this. If it's the second strategy, then instead choose box function equals choose random box with memory. That's just a copy and paste of, well, I wrote it out, but that's this function right here, right? So choose random box with memory. Sometimes it's better to copy and paste so you don't misspell it. But yeah, right now we have connected this strategy to choosing the right function and putting it in this choose box function variable, no matter what. Now, it is nice, just to protect ourselves from future mistakes, to have an else clause here to say show error, just like we do up here, with invalid strategy. And then just return. We don't, just like we did above here, this is another error handling case. This allows me, if I accidentally get the wrong values in here and there is no function, rather than giving me some bizarre error, if I choose random and hit run, it's like, I don't know what this is because it's random 2 that I chose. And it looked for random and random memory, didn't find it. And I was like, this isn't a strategy I know about. And it dies nicely rather than giving some weird JavaScript error. Okay, so, but if you've done everything right and we have just random and random memory, that's the only 2 options they should be able to choose. And so one of them should work. Now, this still doesn't actually do the final piece of this. We have a choosebox function, but we haven't actually used it yet. We would have to use it all the way down here, right? Choosebox function needs to be used down in play one game for student. Now remember, this choosebox function is local to this function. We could either make it a global variable, but better, let's actually do something else. Let's just pass it down through the various functions. So here in in play one game, I'm going to actually pass choosebox function down into play one game. So I'm telling play one game with this box choosing function, either the random strategy or the random with memory strategy. Of course, I have to add it down here, right? If I'm passing it, I need to say I'm receiving it. And then we do the exact same thing again. We say play one game for student using that choose box function. I'm just plumbing this through the various function calls. That's what they usually call this. And again, I have to receive that choose box function here as an input. So notice all I've done here is I chose my box function as we already did, but then I say, okay, play one game with this function. I receive it as an input and I say, okay, play one game for student, for one student with this function. And then down here in the main function that actually plays the game for one student, instead of calling choose random box with memory, I use my choose box function. Oops, that was the wrong button. So yep, you basically just choose box function there with the 2 inputs. And since I passed this down from the top, it will be the correct strategy. If I choose random box function will be inside this variable. If I chose random with memory, choose random box with memory will be inside this variable. So now I've actually swapped the function like I was manually doing before using this strategy, and this will work. So let's click run here. Let's change to 4 students so that we can see the difference. Notice I'm not doing that great with 4 students. I'm winning about 3-point-something% of the time. I changed to random with memory and I'm winning 6-point-something% of the time. So now they're not accidentally sometimes choosing the same box twice anymore with random for memory. That's why we're doing better. And so that's it. We've added our second strategy. In the next part, we'll add a third strategy that does even better. Until next time, bye.